Look up tonight. You will likely see it, a familiar, silvery orb hanging in the vast darkness of space. This is the moon, our constant companion. It pulls on our oceans, creating tides, and has inspired poets and dreamers for thousands of years. The moon is more than just a rock in the sky. It's a part of our story, a celestial beacon guiding us through the ages. For centuries, we thought the moon was a dead world, a quiet, unchanging place covered in dust and craters. We mapped its mountains and vast, dark plains, giving them beautiful Latin names like Mare Tranquillitatis, the Sea of Tranquility. But what if that story is incomplete? What if the moon is not as quiet as we once believed? Science is a journey of discovery, about asking questions and challenging what we think we know. The cosmos is full of mysteries waiting to be uncovered, and it seems our closest celestial neighbor has a few secrets of its own. The quiet, dusty world we thought we knew might be stirring, trying to tell us something new about itself and our place in the universe. We are living in an exciting time with powerful telescopes on Earth and robotic explorers in space. They are looking at the moon more closely than ever before, seeing things that make us question the old story of a silent, sleeping moon. The evidence is mounting. Something is happening up there. The moon is buzzing with a new kind of energy, inviting us to look closer, ask new questions, and embark on a new quest for understanding. For a long time, the moon was a symbol of stillness, a place where nothing ever happened. The footprints left by the Apollo astronauts are still there, perfectly preserved. This unchanging nature made it valuable to scientists, a snapshot of the past, frozen in time. But astronomers have been reporting strange things for centuries, called transient lunar phenomena, or TLP. These were fleeting events, a brief flash of light, a temporary reddish glow, or a patch of the surface that seemed to become hazy. For a long time, these reports were dismissed as tricks of the eye or problems with telescopes. However, our technology has improved dramatically, with robotic eyes in orbit around the moon. These new tools confirm what early observers suspected: the moon is not completely quiet. The flashes and glows are real, and something is happening that we cannot easily explain. We are seeing patterns and gathering data, forcing us to rethink everything. If the moon is active, what does that mean? It opens up a whole new chapter in our exploration of our nearest neighbor. The silent world is whispering, showing signs of a hidden life, not biological, but geological. The moon is more than a museum piece. It is an active, evolving world. We are just beginning to listen to what it has to say. The silence has been broken, and the story is just getting started. Imagine staring at the moon through a powerful telescope, watching the dark part not lit by the sun. Suddenly, you see a brilliant, tiny spark of light that lasts for only a fraction of a second. Projects using automated telescopes are now capturing these flashes on camera, providing solid proof they are real. The leading theory is that they are impact flashes from small meteoroids hitting the lunar surface. These tiny projectiles create massive heat upon impact, vaporizing rock and creating a brilliant flash of light. Because the moon has no atmosphere, even a rock the size of a walnut can create a flash bright enough to be seen from Earth. This explanation fits with what we know about the space environment, but it might not explain everything. Some observed flashes last longer or have different colors, leading scientists to wonder if something else is at play. Could these flashes be caused by activity from within the moon itself, like gas release or static electricity discharge? Studying these flashes is crucial for understanding the environment between Earth and the moon. By counting them, we can understand how many small objects are hitting the moon, vital for planning future missions. When we send astronauts back to the moon, we need to know the risks and design habitats and spacesuits to protect them. The flashes in the lunar night are not just a curiosity, they are a crucial data point for the future of human space exploration. Beyond the fleeting flashes, we are seeing new, permanent changes on the moon's surface. With powerful orbiters like NASA's Lunar Reconnaissance Orbiter, we have been mapping the moon in stunning detail. Scientists are discovering new craters that were not there just a few years ago. By comparing before and after images, hundreds of new impact sites have been identified. The ancient, pock-marked face of the moon is still acquiring new scars, a dynamic process happening constantly. The lunar surface is not just a relic of the past. It is being actively reshaped in the present day. When a meteoroid strikes, it churns up the soil, a process called gardening, mixing the top layer of lunar dust. This constant churning means the lunar surface is younger than we thought, constantly refreshed by cosmic bombardment. The story written in the lunar dust is not a finished book. It is still being written, one tiny impact at a time. We have flashes of light and fresh craters, likely from impacts by space debris. The moon, without an atmosphere, is exposed to constant bombardment, creating the flashes and craters we detect. But some phenomena, like hazy glows, are harder to explain with simple impacts. This has led scientists to look for answers from within the moon itself. Data from the Apollo missions detected moonquakes, suggesting the moon's core might still be hot and partially molten. A warm interior could release gases, seeping through cracks and escaping into space, creating temporary hazes. This idea of a gassy moon suggests it is not a solid, inert ball of rock, but a world still breathing. It exhales gases from its interior, a subtle sign of the heat that churns beneath its cold, gray surface. This paints a picture of a more complex and active world than we ever imagined. To solve these lunar mysteries, we need a closer look, and our best detectives are robots. Missions sent to orbit and land on the moon are our eyes, ears, and hands, exploring where we cannot yet go. NASA's Lunar Reconnaissance Orbiter has been circling the moon, creating the most detailed maps we have ever had. It carries instruments that help us understand the moon's strange behavior, like a laser altimeter and temperature sensors. Landers like China's Chang'e program have been successful, exploring the far side of the moon. These robotic explorers gather raw data, helping us build a more complete picture of what is happening on the moon. The discoveries made by our robotic detectives have sparked a new race to the moon. We are entering a golden age of lunar exploration, with more missions planned by more countries and companies than ever before. Nations like the United States, China, India, Russia, and Japan are planning ambitious missions, including human habitats. A major focus is NASA's Artemis program, aiming to land the first woman and the next man on the moon. Private companies are playing a huge role, making lunar access cheaper and more frequent. This new activity will generate unprecedented data about the moon, helping us monitor its activity in real time. Why does all this matter? The moon is a part of our cosmic neighborhood, key to understanding ourselves. It holds secrets to the formation of our planet and the early history of the solar system. Studying the moon is practical, providing a baseline for the threat of impacts throughout the inner solar system. The potential for resources like water ice is a game changer for space exploration. Beyond science and resources, the moon inspires us, pushing the boundaries of human ingenuity. The quest to explore the moon unites people around a common, hopeful goal. By continuing to watch, study, and explore it, we are learning about our past, securing our future, and taking our next great leap as a species.